Hello everyone, welcome to our channel. In this series, we are going to cover the control system previous year questions asked in GATE exam. So this series is very helpful to cover all important concepts generally asked in the examination. So here, first question we are taking from the lead compensator generally in control system control compensator question frequently asked in the exam. So here we are taking from lead compensator. So they are asking, they find out the frequency at which our phase should be maximum. So for this, how to find out the frequency? So this is uh, very simple question. As we know, in a transfer function, they given one corner frequency 1 by 3t and one more transfer corner frequency 1 by t. So as we know, like frequency for which uh, phase should be maximum. So frequency is a geometric mean of the corner frequency. So 1 by 3t into 1 by t. So you will get the one straight away answer 1 by 3t square. Alright. So here answer is B. Option is B is correct. Okay. But how to get this condition actually? For this we need to drive the this condition. Okay. So here one more thing we want to tell here. This is lead compensator. So here like we just write one simple transfer function in terms of s plus a by s plus b. Okay, so if how we will check, how we will recognize this is a lead compensator, lag compensator, but sometimes they don't, you know, highlight actually. This like a simple compensator. So we should ensure that whether it is a lag compensator or lead compensator. So here, in case of lead compensator, zero is near to pole, near to origin, and we can say zero dominant pole. Transfer function which is zero near to origin, like this is S plane. This is my J omega axis. This is a real axis. So here we can see this is a zero. Zero is a we are generally present in a circle, and this is a cross. So this is pole. Okay, so minus A and minus B. All right, and one more thing here, a less than b regardless of sign actually. So we can say a absolute, like, okay na. So it should be, then only we can say this is lead compensator. And one more thing, like if you draw the body, here we get better picture, like like what is the body plot of the lead compensator generally be like that. This my and this my magnitude, okay, in dV, and this is log omega. This my one crossover frequency, the generally is 0, okay, and this is a omega 2 digit pole. So as we know, but a 0 in pole, in case of transfer function, 0 is a numerator polynomial roots actually, and poles is a roots of denominator polynomial of the transfer function. So like s plus a, this is my numerator polynomial. So this root is called the zeros, and s plus b, this is denominator polynomial. So this is called the this roots is known as the poles in a transfer function in a control system theory, right? So further, our we also draw the phase plot. So as we know, B is coming like that. Okay. So we need to find out this frequency at which we get the maximum phase. Okay. This omega naught we can say. Okay. All right. So how to find out this frequency? Okay. For this, we need to drive the drive this condition. As we know already, this is geometric mean of the corner frequency. So for this, we bother about only our phase of this transfer function. So, and one more thing actually I want to highlight here, in case of lag compensator, our like if you reverse the zero and pole location, so this configuration will behave like a lag compensator, like 1 by 3t as a pole, like s plus 1 by t by s plus 1 by 3t. So this behave like a lag compensator. So this basically give the lag. Okay, but we will not go more depth in this. We will discuss this more details in our coming videos. But here our more concept is that like A and B should be in the left hand side. B should be left hand side, then only system is stable. I mean composite is stable, and zeros also should be in a left hand side because we don't want to non-minimum phase system. We will discuss in upcoming videos like what is a minimum phase system, what is a non-minimum phase system. Okay, what is the limitation we come across if we deal with the non-minimum phase system. All right. So here our focus there we have to drive it this condition. So like we have to we have to drive for this simple transfer function, and we have to apply our main questions. So like ts is equal to s plus a by s plus b. Here we are saying a b greater than 0 because we want to system is stable and non-minimum phase. Okay, 0 should be in also left hand side. All right, so here and and condition already we tell a less than b for lead component. We will see how we are getting this a less than b. So for this we have to write down in the j mega. So just substitute s equal to j mega plus a by j mega plus b. All right, then find out the phase for this. So as we know, this is a complex value, this is a complex, this is also complex, this is also in phase first quadrant. So there will be no problem. Straight away we can find out tan inverse imaginary part omega by a minus tan inverse imaginary part omega by b. All right, and then and here you can see like we want positive value, right? It should be positive, right? So how it value positive then for same frequency a should be less than b, then only this value, this term value greater than 0, greater than for this value. Okay, so that way we get the a less than b. For this we can say our 0 is near to origin and pole is far away from the origin, right? Okay na, here we can say also tan inverse x we can see it's coming like that, right? Okay, and it is saturated on the pi by 2 minus pi by 2, right? So this point should be more than that, this omega by a. Okay, this angle, and this angle should be near to the, then only if you subtract it you will get the greater than 0 value, means positive angle you will get it. All right, so okay, you hope you understood this one. And we are just in order, because we want to have a maximum value for this. So as we know in mathematics, for in order to find out the maximum value, minimum value for the function, we need to find out the derivative and put the 0 and then find out the our points on what which function would be maximum value, minimum value. All right, so we have to find out the derivative here. So here we get tan inverse omega by a 1 plus, as we know, tan inverse x, what is the formula? 1 by x plus x square. Okay, so here omega by a whole square, and we are applying chain rule also here. So derivative of omega by a, earlier we apply the function tan inverse omega by a, and after this omega by a, this is our algebraic function we can say. Okay, so here omega by a omega, so we'll get the 1 by a, right, minus 1 plus, similarly we are applying in this next term actually, into 1 by b. All right, so we want this should be 0, then we find out the omega frequency, so we get 1 by omega by a whole square into 1 by a. All right, and 1 by 1 plus omega by b whole square into 1 by b. All right, and then just we are further simplification, just cross multiplication and then solve further, then you get the b1 plus omega square by b square equal to a 1 plus omega square into divide 1 by a square, right? Then b plus omega square by b equal to a plus, just b are multiplication b, okay, and then cancel out b square and into b, okay, and omega square by a. All right, okay, then just we collect the omega square in one side, and then you get the a minus b. All right, then a minus b, I am just simplify this, a minus b minus a minus b cancel out, omega is equal to under root a by plus minus. Okay, so we have to ignore this plus value, will get the we ignore the negative value, will get the under root ab. Okay, because we are saying that function should be lie in the negative here now, so it should be automatically the negative value actually, because already in the we are conditioning, we are saying that s plus a by s plus b, it should be in a right left hand side, so it should be in a positive value. Okay, so we get the value, in our case we get the under root 1 by 3t square. Okay, if you extend this question for what angle, how much maximum value for this, so I am just what is the angle for this, is a tan inverse omega by 1 by 3t, right? So 1 by 3t minus tan inverse omega by 1 by t. All right, so tan inverse you will get 3 t omega minus tan inverse t omega, and just replace this, substitute the omega value, and then get the maximum phase. So 3t omega is value is under root, right, 3t square. Similarly my tan inverse t into omega, omega is, we can t come out outer side also 3, like that. So how is coming like that, tan inverse 3t into t is coming out under root 3 minus tan inverse tt cancel out 1 by root 3. All right, and then here we get tt cancel out root 3 minus tan inverse 1 by root 3. As we know, root 3 is a 60 degree minus 30 degree. Okay, root 3 tan inverse should get 30 degree. So one more thing here we can understand actually, in our question, this regardless of t value, whatever t value is coming, is independent of this 3 actually. Okay, so like if you some the question frame it here and like find out the maximum value phase angle also. So this not depend upon the t. Okay, so that's all for this video. I just covered actually like how to find out the frequency, and we should remember this like geometrical mean of the corner frequency. So this is applicable for both like compensator also and lead compensator also. Okay, so like we have seen here lead compensator Bode plot. Same thing we can also find out like this is typically configuration for lag compensator also coming like that. Okay, so here is lag is there. But generally, in case of lead, just for practical purpose, I'm telling to you, like lead compensator, it name itself telling that we have to use for the providing lead in phase. But generally, lag compensator, generally we are not using for as a lag. We are using for the based on our requirement, we use for the giving the more gain in case of lower frequency region, so that we get more gain, and system should be more trackable, system is stable and avoid getting the robustness tracking. Okay, so this thing more depth we will discuss more details in our coming lecture. So here we have understood that how we can find out the frequency and what is our maximum angle. Maximum angle is 30 degree for this. Okay, so all right, thanks all. Please support to us, support our channel, and definitely yeah, we will this is series very helpful for understand all very concepts related to control system. Thanks all.